Hello. Today I'm going to be telling you guys about plate tectonics and the many different ideas around plate tectonics. The Earth is comprised of many plates, kind of like a puzzle. It's important that we know what they're called. We have the Pacific Plate, North American Plate, Eurasian Plate, African Plate, Antarctic Plate, Indo-Australian Plate, the Indian Plate, and South American Plate. There's going to be a picture up, hopefully up in the top over here or after this clip, that breaks down all the plates for you. Now, you may be wondering what makes these plates so important, and that's because they formed where you live today. Well, a little bit. When Alfred Wegener saw that the continents look like they fit together in a puzzle form, kind of like this, it sparked his idea that the plates were not only in this position where they saw them. It was called continental drift. He also found fossils in South America that were also in Africa, which couldn't even swim. So what was the explanation other than they were once connected? He could also tell based on glacial evidence on continents like Africa that would never have glaciers otherwise. I mean, come on, Africa's pretty warm, isn't it? Later on in the timeline, Alfred Wegener was removed from the picture by a snowstorm during an expedition. But a man named Harry Hess came along. He used sonar to measure the deep ocean floor, and in around the middle of the Atlantic and other areas, he found mountains with flat tops. This discovery sparked his idea of seafloor spreading. The basis of seafloor spreading is his theory that magma rises up in the ocean floor and then hardens and pushes the two plates apart, whilst making a magma mountain called a mid-ocean ridge. You may be wondering what happens when the oceanic/water plates being pushed apart meet the continental or land plates. This brings us into our next topic, which is plate boundaries. When two oceanic plates diverge or go away from each other, like so, this forms a mid-ocean ridge and also has something to do with seafloor spreading. So the mid-ocean ridge opens up and the magma under comes up and hardens, which pushes away the two tectonic plates and goes into our next plate boundary, which is the continental and oceanic converging. When an oceanic plate here meets a continental plate here, the oceanic plate gets subducted because it's denser and will just get subducted under. Subduction is basically this, where a plate goes under another. This creates a deep ocean trench right here about where my hands meet. And not only does it create a deep ocean trench that, just like its name, is very deep, it creates volcanoes and earthquakes, just like almost every plate boundary when it connects or diverges. When they come together, this is called a convergent plate boundary because they're converging on each other. That's just some knowledge that you should know. Our next one is two continental plates, so land plates, converging on each other. Since the one can't go into the other because they're the same density, they go straight up and form a mountain range, like if you think of the Appalachian Mountain Range, the very long range, and that's because the plates are long, so they connect, and the whole entire down the plate is just mountain range. This can create mountain ranges, of course, and can also form earthquakes, like a lot of other plate boundaries. Two oceanic plates converging creates an island arc. So the two oceanic plates converge, they go up and creates an island, kind of like an arc. It's like a volcano island. So it creates volcanoes, and you guessed it, it also can have earthquakes involved. And lastly, when two continental plates separate, they create a rift valley. So when they separate, what else is going to be there than just a deep valley? And that's what it creates. Our last topic is hotspots. Hotspots is where magma rises up from the outer core to the top of the oceanic plate, forming an island. So the magma rises up and it hardens because it's cooler, of course, higher up in the earth, and creates an island. like Hawaii. I'll have a picture of Hawaii here, and hopefully, or after the clip, and then a diagram after the clip as well. But the Hawaii Islands are in a line, and all the islands are just in a straight line, and this is because of continental drift, which was our previous year we talked about, and because the continents move, so the islands move with the continent, or the tectonic plate, and they move away, but the hotspot doesn't, because tectonic plates are on the lithosphere, and that is kind of towards the crust or the mantle in that area, and the outer core is obviously not part of the mantle or the crust. Now the islands have moved away, and the magma starts rising again, up, and creates another island. Obviously, it doesn't happen as fast as I'm saying it, because it takes millions and millions of years to just form one more island. So maybe in a million, like 2 million years or so, we might see another island. We might see another island in Hawaii. Thank you for watching my quick presentation on tectonic plates and the many theories around it, such as hotspots, and a quick history on them as well. Thank you.